Can you see this?
Evening, sir.
Can you see this?
Yes, sir. Sir, your input volume is very low, sir.
But you're again disqualified today because
Please.
I joined first.
Makes no sense there. I joined right in time.
No, you joined 2 minutes ago because you skipped last class.
I didn't skip anything. I was attending that
No,
class and
that's
I
you're
muted this
disqualified.
in
I'll go.
this.
So,
Sir.
um,
Oh,
Okay,
sir.
so you're
so you gave.
Nitish?
Sir, your input volume is very low, sir. I think you have to
Oh, I
increase
thought
it.
I lowered my. Oh,
It is very low.
now
Yes,
we can
sir.
hear
Now
you.
it's okay, sir.
Now
Sir,
it
my
is okay.
computer is hot. So hot, sir. I can't
Okay.
even touch it, sir.
Dude, computer is learning from
Laptop.
chemical reactions,
Laptop.
sir.
So anyone which like who
Sir,
was
I was actually thinking of we can discuss the maths exam paper today, sir.
which exam papers?
Our term exam from our school.
Literally.
No need.
This is not for this.
Oh,
Have extra for that maybe.
Hmm. Okay, so anyone has any other question?
no, sir.
No, sir.
So we'll continue and finish our midpoint theorem chapter today. We'll see the
Let's
last
do.
which is a small thing,
I'm
and
not able to
basically,
see the screen.
yeah,
Everyone?
it should be able.
No.
Yes, sir. Now I'm able to see.
So as of now, you all have seen two things. First, midpoint theorem, which states that if in any triangle you join the midpoints of two sides, then the side is going to be parallel and exactly half of the third side. The second thing which you saw was converse of midpoint theorem.
Yes,
That
sir.
is, if you start a parallel line from midpoint of one side, then it is going to hit the midpoint of the other side, and the line segment newly constructed is
This is
half
a
of the
recap.
third side. Okay,
No,
this
it's a
is
new
a
topic.
new thing. This is a new thing, and we will call it a transversal theorem. Okay, the name which we are going to give it is a transversal theorem.
Damn, I already found out the answer.
Dude, the chances of it being wrong are high.
No, sir, I found out the answer already, sir.
Fine. First of all, let us understand what it
Yes,
says.
sir.
Okay. It says that if you have three parallel lines and the transversal makes equal intercepts on these three parallel lines, so any other parallel line also is going to do the same thing. Any other line which acts as a transversal also is going to do the same thing. That
I don't
means,
get it.
yeah. So see, I have three parallel lines L, M, and N. Okay. It is having a transversal AB. This AB. So the AB, what it does, it is put in such a way that the length of the line segment between L and M, denoted here by PQ, and the length of the line segment between M and N, the parallel lines, denoted as QR, they are made to be equal. Okay. This is
Sir,
given.
L and M and M.
No, PQR. So it's like this. See, let's say I have three parallel lines. Okay. And I have a transversal. I put it in such a way that these A, B, and C, AB is equal to BC. Okay, these three are parallel lines. This is a
Sir, but
given starting condition. It is the assumption. Okay, assumptions has these parts, three parallel lines and a transversal making equal intercepts. Then it says that if you have these assumptions, no matter which line you create, okay, no matter which line you create, passing through the parallel lines, either this or this or this or anybody, the intercepts between these lines are going to be the same.
Sir,
sir,
the
so
answer is already
basically,
done, sir.
sir, so it's
Equally done.
basically AB is equal to PQ is equal to LM because it can intersect anyway, but it will be same.
Sir, then this question is like super easy, sir.
Without using midpoint theorem, da. It's like a different.
Hmm. So it is claiming that at the end, LM and MN also are same. That's what it says.
Yes, sir.
So if I have these two lines, then
Sir, I'm done,
I
sir.
am saying
So easy.
yes, yes,
Like
yes.
at start itself. Da. What are you talking?
So 1, 2 is
I
equal to
wouldn't even
2,
know
3,
this.
Yeah, I
and
did it
4,
already.
5 is equal to 5, 6.
Yes, sir.
That's what it says. So why?
What? Why, sir?
Why it happens?
Why? Why? What happens? I
Why transversal theorem happens?
So this, I'm saying, can you prove LM equal to MN under these given conditions?
so we can't use midpoint
Because,
theorem, right?
sir, sir, because when we see BPLD is basically a parallelogram, and according to parallelogram, midpoint, and when the midpoint is joined parallel to the baseline, and it joins the midpoint of the other side, which is the midpoint of it.
BPLD
Yeah,
is not a parallelogram.
sir. Sorry, I mean
Trapezium.
trapezium.
Huh? So in a trapezium, when you
Sir, so
join the midpoints,
when you join the midpoints, sir,
You
it's
make
like in
it
a
complicated.
trapezium. See, so it's easy, though. Like when in a
Yeah.
trapezium, when you take the midpoint of PR, which is Q, and draw a imaginary line parallel to RN, the other side it will like intersect at a point, right? So that point is the midpoint of side LN, because
yeah.
that's how
So we
trapezium
The line
have
is
works.
already
we
there.
okay. Which method do you have?
Me, sir.
Anyone, everyone.
Sir. Oh, yes, sir. So it's given that so direct interpretation of the statement given above, we can conclude that PQ equals LM.
Okay. Why so?
Sir,
Okay.
that's the statement given, sir.
No, it is nowhere said that PQ is LM.
Second.
We
Oh,
can
sorry,
arrange.
sir.
PQ
Oh,
is
my bad,
not
sir.
Yeah.
like
Okay, LM,
PQ.
sir.
Uh-huh.
So like if the parallel lines already cut a given line, that is AB, into half equal sides, then line CD should also be cut into two equal intercepts.
Yeah, that's
Sir,
what is to be shown.
Yes, sir.
sir,
So,
or we can do like the previous sum, like the
I know,
previous
cut
class.
like put a line between P and N, and then first
P and
is
N,
midpoint theorem. That's what I did.
P and N. Sir,
P and
sir,
N.
like draw an parallelogram, like B, P, L, and a point between B and D. Then
Okay.
we use the
hey,
parallelogram
stop
for.
doing.
Mm-hmm. Okay, got
No,
it.
my
Mm.
technique is like I
Uh,
can draw a line from that a point P to point N, and there will be two triangles, and Q is the midpoint of P and R. It is parallel, so it'll reach the midpoint of midpoint of the other side. And then if I do the same thing here, we can say M is also the midpoint of L and N, and then that means LMN and MN the same.
Yeah, you
uh-huh.
can
Okay.
also do it that way.
Yeah,
Okay,
but we're not
so
supposed to do that.
just a second. So this picture is really nice, and it's
Very
showing
nice.
Well,
no
mute yourself.
complication.
You're blowing a lot.
It is a no complications. Let me show you what can happen actually. So I might start with a line like this and a transversal like this, where the line segment PQ is equal to QR, right?
Yes, sir.
Now I don't take this so-called easy line LM. I instead take a line like this
So,
and
but
name it as L, M, and N. The result says, this transversal theorem says that if as long as these three lines are parallel and PQ is equal to QR, then also LM and MN are same. So are your arguments going to work for this as well
Yes,
that
sir.
you put?
Yes,
I'm pretty
sir.
sure
Okay.
mine is gonna work for this, but that's not what you're looking for, sir. I am pretty
Sir,
sure.
Will work, sir.
sir, it
It
will
will work.
work, but the thing is,
Uncle,
over
let
here,
someone speak, da.
okay, speak there.
I started speaking. So,
Yeah, tell.
considering that these three parallel lines are equidistant, and if it's equidistant, any line going through it will also be intercepted into equal lines.
So why?
So, because any straight line passing through a bunch of parallel equidistant lines will make
Why,
equal slices. It's like common
Sir,
logic, sir.
you
sir,
If
it
can't
three
will
tell
equal,
converse
do
Okay,
this.
midpoint
okay,
theorem.
okay.
Tell me
I
it will
got your
converse
point.
midpoint theorem.
Everyone can
I
say
got
that.
I got your point. But
like
the thing
common.
is, what you are
Yes,
saying
sir.
as common, okay, what you are saying as common is based upon certain facts. I am
Sir, but
trying
But
that's
to.
how it works. That's how it
how
works for
how did
like
the first person
trapeziums, right,
invent it?
sir?
How
That's
did the first
exactly
person?
how it
Yeah,
works
it's
for
common sense,
trapeziums,
ra.
right?
Even I could
Hey,
have
how
invented
did the
common
first
Hey,
sense.
person use common
Konguel,
sense?
Konguel, it's not like that. Duh. It's that's how trapeziums work. When you like draw two parallel lines and you draw a parallel line between and you intersect a line, that's what converts midpoint theorem is, right, sir?
Yes, exactly. So the strategy where we did the trapezium part was like we joined P and D, correct? Right?
Yeah.
So
Yes,
Yes,
sir.
sir.
that is one thing. Of course, it is working. It is working because I joined P and D in that case.
And make two triangles. We can do that.
P and N, basically,
P and N.
Sir, any
right?
straight line passing through uh uh three like equal any equidistant line will make like equal intercepts, right? So it's like
Just say
It is very
how
common
is
sense,
common.
right, sir?
Yes, yes, yes. I get your point. I'm not saying you are wrong. I get your point perfectly. The only thing is that what is common for many people may not be a direct logic. Okay? So I'm just trying to explore on what basis you are saying it. Don't tell me common sense. Is there a mathematical reasoning behind it?
Sir,
Yes, we can draw an imaginary line
between
M to the like a perpendicular line passing through N from parallel line P and R.
perpendicular line passing through
M, that is
M.
P and R. Passing through M, sir. It's passing through M, and it's from P to R.
Okay. Mhm.
How is it a line? Let's go. It will go like this.
Like this.
It's top.
No, sir. I'm actually talking about the diagram that you. Okay, I was talking about the
Okay.
diagram that you gave, sir, at the bottom.
Uh, the thing is,
Uh,
see, I'll give you one more set of parallel lines. Okay. It could be like this as well.
Who's it
I mean,
parallel?
one transversal.
Okay.
sir. Yes. That
Uh,
point, like next to, on the same line as Q, there's a point on this transversal, right, sir? Can you just mark it?
okay. This is A.
Yes, sir. A line perpendicular to a perpendicular line from P to R passing through A, sir.
Okay.
Oh,
Line from
perpendicular
P
line
to
like
R
this.
passing through.
Oh yeah. Okay. Okay. I get it. Sir. So you have to drop.
So it's
Like this.
perpendicular to like P and R, sir. No, like
It is
straight line.
perpendicular, da.
Sir, P and R, sir.
Perpendicular.
perpendicular.
Only. What are you
When you
talking
say
about?
Sorry,
The
perpendicular?
perpendicular.
L and R, L and R, L and R. Just three
See,
parallel lines, sir. I'm talking about the parallel lines. They aren't named, sir.
okay, fine. Okay, I get your point. So you are hoping that it will work, correct?
Yes, I just proved those two triangles are congruent. It's
Yeah, yeah. Ultimately, it is like that. And as far as Sankalp you are concerned, you can work out for the trapezium because you in the nice picture you have P, L, N, and R as trapezium. In this, when PQR and ABC are there, or LMN is there, the trapezium doesn't exist, right?
Sir, the trapezium does not exist, sir, but
Uh,
it follows the
yes,
conversion,
yes, yes, yes.
converse.
Okay, tell me what happens with the converse here.
Sir, what is converse? Uh,
There is
what
no
is
midpoint.
converse?
How will you know?
Hmm.
So
And it,
what does converse midpoint theorem say? There is a in a trapezium, the top line is parallel to the bottom line, and when you draw from a midpoint of let's say
No, no.
P and
Converse,
R.
in converse, trapezium is not there. Triangle is there.
Sir, but we
like
just
it's
sir, but we just use converse midpoint theorem in yesterday's trapezium,
Yeah.
no, sir.
that you
So
cut the trapezium.
trapezium is not converse of midpoint theorem. It
They
is
cut
just
that
a
in half.
place. It is just a place where we applied the converse. Okay,
We can
where
still
we
apply
made
it
this.
on any three parallel lines, right, sir?
Okay, apply it on these
Cut it
three.
in half. You can do.
PQR and
think out
LMN.
of the box.
This one. These
Uh,
two. This is the setup. How are you going to apply?
Which is the setup? So like the one you drew.
Yeah.
Yeah. Think outside the box. Stop sticking to like trapezium. Right?
Sir, first thing you have to
Trapezium is not a
say
box.
is draw a straight line in those parallel lines, sir. And can you just draw a straight line, sir?
From where to where?
Just a straight line, sir. Straight, like
That is
perpendicular
where
to
the
those
Horizontal.
perpendicular to those parallel lines, sir.
Okay, anywhere.
Yes, sir. Anywhere.
Okay. Okay.
Sir, now I have to now like you just have to say if the top part is equal to the bottom part. That's when we can prove it, sir, because that's when the midpoint theorem is applied.
Yeah.
So is it equal, sir?
No, which triangle you are talking about?
I'm not talking about triangles, sir. I'm
Ah,
I'm talking
What?
about
You
like
can't use midpoint theorem in random stuff, da.
no,
Tell me, tell me.
See this.
What do you want? Tell me.
sir, like like just mark all those points on that line, sir.
Perpendicular. On the perpendicular?
Yes, sir.
Okay. Then which
A, B, and C, sir.
okay.
Sir, so if you should first say if AB is equal to BC, that's when we can prove that B is the midpoint of that line. Then we can know that the distance between each parallel lines is the same.
So how do you prove AB equal to BC?
Yes, sir. That's the thing you should tell, right, sir?
Hey, it's already
Oh,
given, no, sir. It's already given
They,
PQ and Q are the
they,
what
same,
is
right?
yes, fine.
Congo, that is a different question. This is the one we are doing right now. I'm not talking about that question. I'm
No,
talking
in
about
this
this
diagram also
question.
it's given. In this diagram also it's
Yeah,
given.
PQ is equal to
Look at the
QR.
left.
Sir is given.
It's given.
Okay, sir. So AB is
Okay,
equal to okay. AB is equal to BC. So it's given.
What?
how?
Sir, now
Why?
the
How
midpoint
is the
theorem.
question, da?
Huh?
How is
Because
the
it's
question?
given. The PQ is equal to QR. It's given. Sir wrote it 2 lines.
Da? How can you tell AB is equal
First
to
of
BC
all,
then?
first of all, you
That's
have some
exactly, sir, but that's exactly how converse midpoint works, right? Like when
You
you
need a
put a
triangle, da.
when you get when you like strike an intersecting
We need a
line
triangle,
to
da.
parallel lines, the
Where's the triangle in this, da? Uncle, tell. Where's the triangle in this?
this is the picture of converse of midpoint theorem. Where do you want to apply it?
lines, sir. Let's make this 3 lines into a parallelogram and then explain, sir. Like because we can do that also, right, sir? We can do that, right?
Uncle, it's a complicated way of doing it, da.
Okay, first of all,
Hey,
Why would someone listen to you
what do
if
you
you do it
okay,
that
talk?
way?
just a
Calm
second,
down.
just a second, everybody silent. Okay, enough. I realize that uh, probably you people are not fit for any discussion.
That's all because of Congo. Actually, it's everyone and you.
What?
So he just he just
Why do
made
you like pinpoint at people and prove them they're wrong? It's just my opinion on it.
Relax.
I never said you're wrong.
So see, first of all, whatever is the setup, we are from the point P. Just a second.
oh.
So from the point P, nobody will be stopping us to draw a parallel line to CD, right? How much ever way the complicated CD is placed, I can always draw a parallel line from P to CD, right? So I make sure that it is like something this way. So this is one parallel line. I give the name as A, and PA is in such a way that PA and CD are parallel. Likewise, nobody can tell me that from the Q point you cannot draw a line parallel to CD. So I will make it in such a way that this tube is passing through the line segment BD, and I give it the name as T. So QT is parallel to CD again. Okay, so this much I have. Now
So
I look at,
QT is parallel to PA also.
yes, of course. So in triangle PQA and triangle QRT, I look at these two triangles and I see that angle, first of all, PQ is equal to QR because that is given.
Yes, given.
Then I have
So PA is equal to RT.
angle PQA is equal to angle QBT because they are parallel lines, so they are same angles.
PA is equal to QT because parallel lines and on parallel lines.
No. QT
What?
is not PA.
QT and PA, sir.
Sir, angle QPA should be equal to angle
Yes.
RQT.
So angle QPA is equal to angle
Angle RQT.
RQT. and that tells me that angle side angle implies that triangle PQA is congruent to
Congruent.
triangle
R
QRT.
Angle RQ, I mean QRT.
QRT.
It's telling,
CPCTC
sir.
tells me, brother, you need to, really have patience. You need to understand that the line CD is different than PA and QT. Okay, our mind says a lot of things. Some things are direct, some things are very logical to us, but there is always a standard base to it. Okay, all this setup in the school is told to find that base. Okay, getting my point?
Yes, sir.
Yes, sir. No,
Yeah.
I was just trying to prove the same.
So CPCTC tells me that PA is equal to QT. Now see, can you tell about PAML, what it is?
It's a parallelogram.
Because I have
Sir.
All sides are
both pair
parallel.
of opposite sides
Like
parallel.
opposite sides are
Parallel.
parallel.
This is parallelogram,
Same goes for
which
QT
means
and
that PA is equal to LM.
LM.
Similarly, QTDM is parallelogram. It means
It's
that
QT and
QT
MN
is
are
equal
same.
to MN. That means because PA and QT are same, so LM and MN are same. Is that understandable?
Yes, sir.
Now
Yes, sir.
see the way of proof. It is of course a nice picture where CD is placed nicely, but I can place CD in whichever way of I want, and nobody will stop this reasoning. Why? Because always I can draw a parallel line from P to CD. Wherever the line CD is placed, there will always be a parallelogram constructed in this way. Similarly, I can always draw the parallel line from Q. Wherever the CD line is placed, it is always going to form a parallelogram. For example, if I have these parallel lines which have equal intercepts at this, and I now take the parallel line and I now take another transversal like this. How is it going to be the construction? This is P, this is Q, this is R. From P, can I draw a parallel line? Of course I can. It is going to be which way? Like this.
Tractor.
From Q, it is going to be like this. Understandable?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So this is which line? This is the line with name. So LMN. So this is L, this is M, this is N. Which parallelogram are we talking about? This is A, this is T.
QT, QMNT.
QMNT, PLMA, right?
Yeah, PLMA. Yes, sir.
Yes. So which triangle we will show that they are congruent?
Sir,
QRT. No.
sir, take that point.
LP something and QM
Hmm.
something M.
QM something. You can give that
Something.
point as oh.
LPO.
PQA triangle and
Oh,
QA.
QRT.
QRT.
That's what we took, no?
Oh, yes, sir.
In those triangles, you are given first of all PQ is equal to QR. Again, angle side angle will come. You will have QT equal to PA. But then QMNT is a parallelogram, LPAM is a parallelogram. So MN will be equal to LM. Getting the point?
Yeah.
Yes. The thing is, your way of construction as well as the way of proof should not get obstructed by the placement of the line ln. In whichever way it is placed on three parallel lines, that much construction should be valid. Then only it makes sense to speak a word about what you want to prove. Okay.
Yes, sir.
Yes, sir.
So
Not telling you that you are wrong, but I'm telling you to be little sensible of what you all four are speaking. Okay.
Four.
Yes.
three,
Bro.
sir. Three.
They.
Three, sir. Only three, sir.
Is not there.
So is
He's
that
not.
speaking,
He's
sir? You
not
only said
speaking,
speaking,
sir.
sir. So you only said
I'm doing nothing, sir.
You are writing, no?
Yes, sir. Yes.
yes. Me.
Fine.
Show us.
Okay. So let's see now a question.
Sir,
And
but can you just say like if converse midpoint theorem works for this, sir?
If you make a triangle, you can do.
okay. So let me show you what is the situation. The remark is
Yes.
this is midpoint theorem, converse of midpoint theorem, and
Transversal theorem.
transversal theorem. So
Keep
transversal theorem implies converse of midpoint theorem.
and converse midpoint theorem.
They are individual entities. Okay. This is the relationship. First, let's see a question. We will come to this. Be sensible when you give a suggestion. Okay?
Can I give my suggestion on that question, sir?
Question.
The question we just did know.
Unless it's not stupid.
Yeah.
Let's
It's
you give
100%
it
will work, sir.
you give it on this
Give it on which, sir?
this one.
This new question that sir is about to give.
Oh man.
Okay, so whoever raises hand first gets to speak. Everyone
Oh,
mute.
oh, I don't want to speak. It's
Sankar, think properly and then raise your hand. Don't do this.
No, I was just trying
just
to
wants
say
to speak.
Pongal. I'm gonna find it before you.
To speak. No.
Okay, mute.
To help you, what is being given? A, B, C, D, of course, is a parallelogram. E is a midpoint, so this happens. F is the midpoint, so this happens. GH and then line, they all intersect. We need to show that GP is equal to PH.
Sir, sir, can I can just use like
Midpoint theorem.
converse midpoint theorem, right, sir? Because we in converse midpoint theorem we learned that line that intersects the midpoint parallel line. It is that point is the midpoint of that yeah, like what is that intersecting line, right, sir? That's what we learned in midpoint theorem. Sorry, converse midpoint theorem.
Where is the triangle to start?
We found out converse midpoint theorem only in triangle, but applications of converse midpoint theorem is in trapeziums, parallelograms, and
Which
many
is
other
your
shapes, right, sir?
which is your trapezium?
Sir, I also said parallelogram, sir.
Okay, parallelogram. Which parallelogram?
Sir, parallelogram ABCD.
Fine. What do you want to show?
Sir, we know that E and F are midpoints, and line EF, the imaginary line EF, is parallel to AD and BC. So there are three parallel lines. So there is an intersecting line GH, and it is the point of intersection is P of line EF. So according to converse midpoint theorem, point P is the midpoint of GH, which makes GP equal to PH.
Uh, so when you write your solution, you don't say there that it is an application of converse of midpoint theorem. You state your midpoint theorem converse, apply it on your parallelogram, and then start solving this question.
Yes, sir.
Right?
So can I tell, sir?
Yeah, tell.
So we can just is construction allowed? Okay, I'll just start. Like I'll just did we say okay? I'll just draw a line that'll go over the point P and is parallel to AB and DC. That means it'll create two parallelograms in general, and then I can um, maybe I can like do congruency rule on it'll form two triangles like if I make that line the uh, the line that will be parallel to AB and DC, that means it'll like P is the midpoint of E and F, right? So that means okay, they didn't say that.
One
uh,
second, sorry for to interrupt. 1 second. So can we just like apply the transversal theorem,
Come to it.
sir?
We will
what
come to it. We'll come to it.
No, I'm asking if we can, if
Yeah,
I
we
can just
can.
apply
We
it.
can. We can.
Okay, I'm done. Okay, okay.
that means if I draw a parallel line, that means we can say because EF is like a intersection. I mean, is like a midpoint intersection of both AB and DC. That means it'll also intersect like the new parallel line that we drew. Uh, like the midpoint that we named it as P, and then I can do the congruency rule that the line like LP and PM are same, and then because midpoint M, that means these were the same, and then vertically opposite angles like this P angle and this angle P are both same. After that, uh, because AD and BC are parallel lines, we can say we can do the transversal thing, and when these both are congruent, that means GP is automatically equal to PH.
Done?
Yes, sir.
Sir, can you tell it in 10 seconds?
Yeah, tell.
Lol.
Not in a
Sir,
remark, sir.
DC is cut into two equal halves when passing through three parallel lines AD, EF, and BC respectively, and thus any other transversal cutting through it will be separated into two equal halves. Done.
How are you sure that EF is parallel to AC, AD, and
So
BC?
because yes, sir, when two midpoints of a parallelogram are connected, they always form a parallel line to the respective sides.
Based on what?
So you want me to? Okay, sir. AE and DF are parallel sides, and they are of the same length
No,
because
how they are parallel?
so AE and DF, sir,
AE and DF, yeah, they are parallel. Okay,
they're parallel and they are of the ultimately of the equal distance because AB and DC are of the same distance.
right,
So it
right.
forms a parallelogram, and so we can conclude easily that EF is parallel to AD, which is of course parallel to BC, and there are three equidistant parallel lines which cut another transversal into two halves, therefore cutting
Yes,
any other transversal into two halves.
correct. See, so uh, the thing is,
Mm.
of course, you can use any way you want. I feel the best way is the one which has used common sense and less resources,
So
which
that means
saves
I
your
can.
time also. So
Yes,
basically,
sir.
it is how it goes. AB is equal to
Sir,
BC.
was mine right?
You are long. I mean,
Sir, but I
you
So
said
what
in the
about
first,
mine,
right,
sir?
sir? I
you
said
are
in the
right.
first.
You are right. But your solution takes a lot of time.
So what about mine,
I'll
sir?
show you.
I got
I'll
B.
show you. I'll show you. Yeah.
So what about
Yes.
mine, sir? What about mine?
Got
You
B.
lost.
I
Sir,
B.
Lol.
I
what's the construction is
Wait a
like?
second.
What?
Yes, Tarun.
What
Yes, Tarun.
is
Tell me.
this guy. where I got BE and FC is a parallelogram. And wait, one second. So you can continue.
Sir,
Yes,
but I did it without any construction, unlike Kongwell and Nitish, right, sir? So
I
you
didn't
can use
construct
You
mine.
still
anything.
got
I
it
didn't
wrong.
construct anything.
But you tried to construct. I didn't
No, I
even.
didn't try to construct anything.
I also tried to construct.
Okay, stop.
AB is DC. That means 2AE is equal to 2DF. AE is equal to DF. And also AE parallel to DF. It tells me that AEFD is a parallelogram. So Sankalp,
So how?
your place comes here. To show AEFD is a parallelogram, you will start with converse of midpoint theorem and then come, which we have received in the fifth step. That is
So,
where time is saved. Yeah.
but how are you telling it's a parallelogram when we don't know if EF is parallel to AD, sir?
I am
Bro,
saying AE is parallel to DF
So,
because
but
ABCD is a parallelogram. No?
oh,
sir,
because they both
I did
sides are,
not,
oh, the
I
sides
did
are
not
same and
take
parallel. Okay, okay.
sir, I did not take two separate parallelograms like AEDF. I took the entire parallelogram ABCD
Right,
and then
right,
I
See,
right.
fair
drew.
enough, you did it right. You did
So
right.
your steps will include the statement of converse of midpoint theorem. Then how did you apply on ABCD? You will show that first. Will it be more than this or less than this? That you tell.
The first step. You don't need to write ABCD is a parallelogram because it's given. And I'll just start by saying I'm applying converse of midpoint theorem.
One word.
And I'll say according to converse of midpoint theorem, any
So
line
this is the place.
Sankalp sir
This is
wanted a
the
yes or no.
place. This is the place that you will get a question mark because the solution which is expected is an answer, but not a question hidden in an answer. For example, I see your solution and I look at this. You are writing that I apply the converse of midpoint theorem on ABCD parallelogram. Should I not ask how? I should ask no. So now I have to find out how did you apply. Rather than pure answer, I am having a question hidden behind the answer. So what do you think should I do? I mean, you come at my place, okay? Take my place, be in my shoes, and then suppose you are getting some solution from your candidate. You are having a question hidden behind an answer. What should be the right action according to you? You tell. Getting my point?
Yes, sir.
So
Yeah.
mine using common knowledge means mine will be correct. So according to maths, maybe wrong. But
According to you, why P is a midpoint of EF?
I'm drawing up. I didn't say it's a midpoint of E and F, sir. I'm telling when I draw a line like a parallel to AB and DC, like in the middle, in the way that it intersects, like in the way it goes over the point P. That means uh
See,
okay,
no?
sir. Okay.
Sir, I don't get what you mean by prove it, sir. I'm saying I'll prove it.
Sankalp, simple da. Your
Like
answer's long.
no,
Hey,
like
Pungu, you
Okay. Okay, tell. Huh? Tell.
sir, like do you like you told us that anything intersecting EF, it's the mid that point is the midpoint, right, sir? Like what else am I supposed to prove?
What anything intersecting EF?
so never said that.
Sir, like in the previous class, like in the last two sums, you just explained us according to converse midpoint theorem. Sir, I don't know the previous class sums, but
Okay.
you just said that anything intersecting that line, that point will be the midpoint of that intersecting line.
Only if it starts from a midpoint and is parallel.
Is like this. There will always be a triangle which has a midpoint, and we start a parallel line from that midpoint. Then it hits the midpoint. So not in anything, in a triangle where these things are available. And wherever we have applied, the triangle is specific, the midpoint is specific, the parallel line is specific. If you want, we can see those questions again. But point is, don't use the word anything. That anything is not the word to use in converse of midpoint theorem.
Well,
Anything is replaced by triangle, where you have a parallel line starting from a midpoint of one side. Getting?
Yes, sir.
Okay, it's not anything that trapezium or parallelogram or rectangle. They may be applications of the midpoint theorem or its converse. Here,
Sir, so I'm supposed to construct an imaginary triangle.
you have to
Oh,
first bring that in the picture, that according to your way, why AEFD or whatever is your strategy, why it works. Okay.
I got another idea.
so can I prove it by like drawing an imaginary line from G to C and then A to H, then telling according to converse midpoint theorem?
If all the assumptions are valid, if all things are correct, you can go ahead. Nobody is stopping you.
Can I tell
You
one
can
thing?
put your 10 minutes. Yeah.
So, like if I draw a line from the point A to C, like that, that means
It may not hit the point P.
why so?
Because GH can be anything, like any.
GH, GH, I didn't even take GH, sir.
Okay, you join AC, then what?
If I join AC, it may intersect, I mean, may go over the point P.
That's what I'm saying.
You're
That's what
telling
I'm
may,
saying.
Nitish, you're telling it may go on, it should
May-
go on P.
It
You
should.
should prove that.
I'll use my scale on the screen.
and it won't.
So
Said it's going,
see,
sir.
this is just a reference picture.
Oh.
GH is any line that intersects at these points. I can push the line GH above. I can even take it well below,
Sir,
where I ensure that it does not intersect the point where you want to intersect. That much freedom the line GH is having. It's not a fixed line. Let me see that clearly.
Like
Okay.
overlay line AB.
Yeah. Okay. So now AEFT being a parallelogram. So AE is parallel to FD. AE is also,
yes.
sorry, not this. AEFD is a parallelogram. That means AD is parallel to EF. AD also is parallel to BC. That tells me that I have a set of three parallel lines where GH is acting like a transversal.
After learning this, midpoint theorem seems easier, sir.
Also, I have the
Everything's a
intercepts
lot easier there.
between these three parallel lines are same. GH being a transversal, it means that by transversal theorem, GP is equal to PH. You know, you are always you are only glued to the picture. Okay, this is not a fixed picture, it is just a reference picture. That means I can always also, for example, in this picture itself, I can do something like this.
Parallel to
That-
GH.
Sir, no. It has to intersect BC, sir.
Just a second. I can do it
That
like
is
this.
correct, sir.
but it won't be
But
parallel.
it has to be parallel to GH, right, sir?
According to your picture, it's
No.
wrong, but maybe it can be parallel.
So now forget the older line GH. This is my new line G dash
Right.
and H dash. So that is the thing. G dash H dash intersects AD, EF and BC. So you see where we have placed. In fact, I can also place the same line GH as this.
But it's basically the previous the previous problem.
Yeah. So look at the freedom what is available in the picture. All right. Do you understand what I'm
Yes,
saying?
Yes, sir. Can we do another question?
Sir, it's like I am glued. It's not that I'm only looking at the picture. It's that I'm glued to the previous topic, sir. Like when I was doing the midpoint, I was looking at
Happens.
congruency. When we were doing converse midpoint, I was thinking of only midpoint. Now when we are doing transversal, I'm only
Happens.
glued to converse.
Okay. So you need to practice to come out of the older setup. Show that AB is equal to AC. And the picture is this.
Same mute yourself. Raise hands first.
So,
Okay,
but for
mute.
me, in the previous question, I did a very big, I did many steps there.
Yeah, that's what I'm trying to say. You can solve by any method. Nobody is stopping you. But don't you think it is justified that you solve in the least time using least resources? Makes sense, no? Like with least time and least resources. You can't spend the whole life solving only one question, right?
Draw a car on the question. Look at the car's wheels diameters.
AB is equal to AC. Why? Show this. That is the question.
So there's like no other thing, like nothing else. That's it.
Nothing. That's it.
Can I use congruency?
Yeah.
Oh, that means it's easy, sir. I think.
Mhm.
Did they say that AC and AC is a bisector of that angle? That is that the case?
Day, Nitish, literally just one sentence is given. The AB is equal. Show AB is equal to AC, and the picture is given. Nothing
Other
Maybe,
else.
than that,
maybe.
I think everything is given. PDC is a line. There are three standing lines, perpendicular lines standing on it, such that PA is equal to AQ. That's it.
Found out. Can I tell, sir?
Then
Okay, sir. Yeah, like congruency I can use. So, angle ADC and angle ADB are same
Yeah,
because
one second, 1 second. Tell what two triangles you're trying to prove congruent first, so that
angle
it's easier.
triangle ABC. I mean triangle ABD and triangle ADC.
enough.
In,
I got
in
it.
that,
I got it.
I didn't say anything, sir. I didn't
I
say
got
anything,
it.
sir. Yes, sir. Thank
Anything else? Anybody else?
you. What?
I don't know
Yes,
how
sir.
you prove that congruence.
Hey, it's
Sir,
easy that
let
you
me.
prove it.
It's
Okay.
automatically
So
proved.
see.
Yes, sir. I did the same thing. I proved that same thing.
So
I didn't say
since
anything.
PB is perpendicular to BC and AD also is perpendicular to BC and QC is also perpendicular to BC, it tells me that
It's a
PB,
trapezium. BPQC
you are
trapezium.
Parallel line.
Yeah, trapezium.
Yeah, because the opposite sides are parallel.
PB, AD, and QC are parallel line, and I have equal intercept between them. So any other
Speaking
line
of,
which is transversal through these parallel lines will also have same intersects. Transversal theorem tells me that
CD and DC are
BC
same.
BD is equal to DC. Okay.
So it's congruent. That means
Now
AB and BC.
in triangle ADB and triangle ADC, first of all,
D is common.
BD is equal to CD.
Proven.
But
Then
doesn't midpoint theorem say BD is equal to DC, not transversal theorem?
How do you use midpoint theorem?
Sir,
it is
because in midpoint theorem we learned when from a midpoint and a parallel line is sent and it touches, like it intersects the other
it is
side, it will.
it
Really?
is an application of converse of midpoint theorem. So you write the statement of converse of midpoint theorem, then prove that application on this trapezium, and then you can of course go ahead. Okay, nobody is stopping
Uncle, the
you.
midpoint should be inside the triangle, like one of the midpoint of the one of the line sides. Not
Angle ADB
yes, steps
is
just can't
equal
walk on
to
water.
angle ADC is 90 degrees.
each.
If I run too fast, it can't.
Yeah, of course, nobody is stopping you. You can do
So
that.
I'm
Only I
Of
can
course.
run that fast, bro.
Angle side tells me that triangle ADB is
And
congruent to triangle
ACD.
ADC, and then
I can tell AB is equal to AC.
CPCTC tells me that AB is equal to AC.
So what was the full form of CPCTC?
Corresponding parts of congruent triangles
congruent
are
triangles
congruent.
Corresponding
are
parts of
congruent. Congruent triangles are
congruent
Corresponding
triangles
parts
are
congruent.
congruent triangles are congruent.
same.
Thus,
Corresponding parts of congruent triangles are congruent.
But
You didn't know what was CPCTC and you attended these many classes of geometry.
I still
What a
answered most
disgrace.
of them correct. Oh,
What do you think I did?
you know what? You also know, right?
It's working in the camera.
okay, fine. So with this, we have finished our midpoint theorem.
Yes.
In next class, we will start Pythagoras theorem.
Sir, let's do
Trigonometry.
Yeah.
trigonometry, sir.
We're doing
No.
that in school.
No, for
Sir,
once the
we,
school is ahead of us.
sir,
No, they skipped like 7, 8.
so they skipped 8 chapters,
We
sir.
will whenever we will come to trigonometry, we'll take up that. But as of now, we'll finish geometry
Sir,
chapter.
trigonometry is so easy, sir.
Sir, it's so
I think.
easy, sir.
Alexi, when you go to a higher level, it's hard.
See, of course, they are introductory questions. They're just made to make you happy. So the little sums you can see that you can apply and you be happy. That's all.
The exam is like
Logarithms,
Trigonometry.
sir, logarithms is our first year and we still feel unhappy that it's a part of our portions.
Okay.
make very
Okay, feel
big
unhappy.
noise. You won't be able
Math
to
is made to make you feel unhappy.
So fine then. You will be getting probably. You might have got
Yes,
assignment
sir.
for midpoint theorem. No?
Yes,
Oh,
So
sir.
yes, sir. I
very
did, sir.
easy, sir.
We also have a test.
Good.
When is this test?
So next
forgot the dates, but
next
it was given on
we
it was
will
given
do
in
the
WhatsApp.
Pythagoras theorem.
Yes,
Okay?
sir. Next class.
Yes, sir.
Fine then. All the best.
Hey, Kongwil,
Thank you,
maths
sir.
makes you unhealthy also. Dude.
Yeah.
Sir,
The
Yeah,
math book itself is
every
very
exam.
sad because there are so many problems. I know it's a very used joke, but stop.
Dude, actually, that's the first time I'm hearing
It's
it.
an amazing joke, bro. When first was made.
I know.
for the first
Okay.
question, I think this is mostly wrong, but for the first question, I
Exactly,
drew a
it's not
line.
like that.
Thank you,
I
sir.
drew a line from P to capital N, an imaginary line, and labeled it as E. In triangle, sorry. Then Q will in triangle PRN. Q will be the midpoint of PR.
Question you are talking about?
The first one.
Okay. PRN.
What? There, Nothing, sir. Nothing, sir.
First, stop
Hey,
feeling
Tarun, it's
shy,
okay.
da.
Say it, duh, but
No.
Stop
Sir, but the
feeling
second
shy,
one,
da.
sir, but the second
then
one
actually,
is got a
it's
very big steps, sir. Like many steps.
But
it's okay. Da, say it, duh, but tell which question
You
you're
saw
telling. It's not
you
that.
saw our solution.
Sir, but
Ah.
yours was so short.
It is what will happen with practice. No problem, no problem. Anytime it happens.
Hey, Tarun, you still didn't even finish your boards, dear sir. Finish all his JE mains and all.
I couldn't
Practice.
even hear what you're speaking.
put your
Okay,
headphones.
How
good
did he
night.
respond?
Yeah.
Oh, your new response